Okay, in this video, we are going to learn about the structure of a parabola. We're going to review some vocabulary we've already learned, and we're also going to learn about some new relationships that we can use to help calculate missing parts of a parabola that we don't know. So let's start by making a parabola. You can just scale it by 1 on both axes. And we're going to start with a point at -1, 4. And then from that point, we're going to go down 5 over 1. It's going to give us our next point. And we're going to go down 3 over 1, down 1 over 1. And then at this point, we're turning back around and going back up. Over 1, up 1, over 1, up 3, over 1, up 5. This should give us a nice parabola. You're going to connect the points. Try not to make it pointy at the bottom. So try and curve around the vertex and then back up on the other side. Let's review some of the things we know. So we know what the y-intercept is, sometimes called the vertical intercept. In this case, it is at 0, -1. We have also learned about the x-intercepts. Sometimes called the horizontal intercepts, or I often call them roots, and you will for sure run across that term in other classes as well, even though I don't think our book really uses that. In this case, they're not exact, right? Like they don't fall in lattice points, so we're just gonna have to estimate them for now. You'll learn more precise methods later. So -0.20 and maybe 2.20-ish. These are approximate. All right, then, very important. All parabolas are symmetrical. If you folded them in half along the vertex, they would perfectly match. So we are going to draw in the line of symmetry for our parabola. It should pass perfectly through the vertex, and each pair of points should be the same distance away from it as you go up, right? Like these 2 points are both exactly 2 away from the line of symmetry. So we always have a line of symmetry. In this case, it is at the point x equals 2, or along the line x equals 2. Now, the line of symmetry is really closely related to the vertex. And the vertex, because it's on the line of symmetry, it has to have the same x-coordinate as the line of symmetry, right? So this vertex would be 2. That is the same 2 as this 2 up here. They have to be the same. 2. And then if we count down, it goes 1, 2, 3, 4, 5. So 2, -5. Something else important to note about this vertex has a minimum but no maximum. So that minimum or maximum value is always the vertex, right? Because that's always going to be the spot where it turns around. So here we have a minimum at -5. We usually just report the y-coordinate when we're reporting a minimum or a maximum. If this parabola had been pointing the other direction, then it would have a maximum instead. Speaking of which, we do identify parabolas as being either open up or open down. So this one is a open up parabola because it looks like a bowl rather than like a mountain. Okay. Let's do another one. This one I'm going to give you less information, and we're going to have to use what we know about line of symmetry and vertex in order to calculate missing parts. This one's going to be a little bit bigger. To start with, I'm going to give you the intercepts and the equation, and we're going to try and build the rest. Okay, so we have x-intercepts at -1, 0 and 6, 0. And then there's going to be a y-intercept at 0, 6. Okay, now what we just learned was that the line of symmetry is always halfway in between those x-intercepts. So if you know the x-intercepts, you can find the line of symmetry by finding the halfway point between them. So you can either do that algebraically, or not algebraically, just by averaging the numbers, or you can kind of visually try and see where it's going to be on the graph. So in this one, I'm going to just show how to find the line of symmetry. So if you take -1 plus 6, those are my x-intercepts. We add them together, we divide by 2. That gives us 2.5. And if we look on the graph, 2.5, sure enough, that does look like it is halfway between those two x-intercepts. So I'm going to draw that line of symmetry in along my graph. Okay, now if I know what the x-coordinate is, that means I already know half the vertex, right? I know that the x-coordinate is going to be 2.5. But in order to find the y-coordinate, I'm going to need to know the equation. And I did promise us the equation, so let's take that now. Y equals -x squared plus 5x plus 6. All right, so if you know the x-coordinate for a rule and you want to find the y-coordinate, you can just plug it in. And when we plug in that x value, it's going to give us the y value. So let's do it. We'll take y equals negative, and then this is a 2.5 squared plus 5 times 2.5 plus 6. And this is kind of yucky looking math. I might want to grab a calculator for that to help me figure out that this is going to be -6.25 plus 12.5 plus 6. And then I can simplify this further. So that's 12.5 minus 0.25. So that's 12.25. So that means that my vertex is at 2.5, 12.25. And so now I can graph it. So that was 6, 7, 8, 9, 10, 11, 12.25. So slightly above. Would be right there. And before I graph this, it will help me graph it nicer if I take advantage of the fact that it's symmetrical one more time to find the symmetrical point to the y-intercept. So this is 2.5 away on this side. It must also be 2.5 away on that side, like so. And that gives me enough points that I should be able to graph my parabola. I can see now that this one is open down. And I found the vertex. I found the line of symmetry. I found the x-intercepts. I found the y-intercept. If I'd been given a context for this, like maybe this was time and this one was height, and this was like a ball being thrown or something, then I might restrict the domain and say that we don't want to go back in time and we don't want the ball to go under the ground. So maybe the domain would be for x values between 0 and 6, if we were saying that this was a ball being thrown. If it had no context, then we wouldn't restrict the domain at all. Okay, finally, let's do a practice problem. I would like you to find the vertex. And I'm going to tell you that the x-intercepts are at 3, 0, and 4, 0. And the rule is y equals 2x squared minus 14x plus 24. If you need to graph it first to help you visualize what's happening, go for it, but you should be able to calculate it just by using the steps from earlier in the video. Good luck.